Hi everyone. As you know by now, power electronic converters are always installed between photovoltaic panels and the alternating current or AC distribution network. Power electronic converters are used to adapt the power output of the renewable energy sources to the needs of the load. Today and during the next lecture, you will learn about the important role of power electronics for the integration of renewable distributed generation. You will get acquainted with basic concepts and elements that will allow you to understand the principles of how a power converter works. Power electronic converters allow us to process and control the flow of electric energy. By means of a power converter, it is possible, for example, to convert alternating current into direct current. Based on the input and the output waveforms, power converters can be classified into four types: AC to DC, also known as rectifiers; DC to AC, also known as inverters; DC to DC; and AC to AC. Power converters are capable of adapting the voltage and frequency of the power supply into the voltage and frequency required by the load. This is done through power semiconductor devices such as the diodes, among others. A diode is a semiconductor device that allows a current to flow in one direction only, from the anode to the cathode. In the figure, you can see the representation of an ideal diode. When the voltage at the input side is higher than the voltage at the output side, a current will flow in the direction of the output. Let's see this in an example. If the voltage at point A is higher than the at point B, then the current will flow from A to B. If a diode is placed in between points A and B with the anode facing the input side A and the cathode facing the output side, the diode will allow the flow of current and it will flow as shown. If a current tries to flow in the opposite direction, because the voltage at point B is higher than at point A, the diode will block the current flow. Let's see now how this information about the operation of the diode will help us to understand how a power converter works. Let's consider this circuit containing four diodes. When the voltage signal is positive, which corresponds to time periods 1 and 3, diodes D1 and D3 will conduct and diodes D2 and D4 will block the current because of the positive direction of the current. Notice that the direction of the arrow in both the input and the output voltage goes from the node highlighted in blue to the node highlighted in red. This means that both voltages are the same in magnitude and direction, therefore the output voltage is the same as the input voltage in time periods 1 and 3, as shown in the figure. On the other hand, when the voltage signal is negative, which corresponds to time periods 2 and 4, diodes D2 and D4 will conduct, and diodes D1 and D3 will block the current. Notice that the direction of the arrows are different in this case. The direction of the input arrow goes from the node highlighted in red to the node highlighted in blue, whereas the direction of the output arrow goes from the node highlighted in blue to the node highlighted in red. This means that the output voltage has the same magnitude but opposite sign to that of the input voltage. As you can recognize, the signal is now positive in all time periods, and if an average line is drawn, you can see that it has a constant positive value. It is therefore said that the voltage is rectified. This could be the circuit inside a power converter. In this case, due to its operation from AC to DC, the power converter can be also called a rectifier. A rectifier is necessary, for example, when connecting a laptop, which operates in DC, to the AC supply socket. The power coming from the socket is AC and is then rectified to DC as required by the load. Today, we analyzed a very simple topology consisting of only four diodes. However, more complex technologies are used to process the input signal into a more constant output DC voltage or into a different DC average value. The topology used today is only a simple example. We are getting closer to the end of our lecture. Today, we covered basic concepts that are necessary to understand the role of power electronics for the integration of renewable sources. We started by classifying the different types of power converters and by understanding how a diode works. Then we discussed the operation of a rectifier using a simple circuit topology. In part 2 of this lecture, you will be able to determine which power converter is necessary to connect a photovoltaic panel to the AC distribution grid. See you then.